Let's talk about solving systems of equations by substitution. These are best solved when you have one equation at least that's already equal to x or already equal to y, or could quickly be solved for x or y. So the steps for these are, number one, you want to plug one equation into the other. So you substitute for x or y. And that's assuming you have an equation already equal to x or equal to y, or you get it there with relative ease, or you'd want to use another method. Then you solve that equation for x or y, because now it's got one variable in there. And then you plug x or y, whichever one you've got at that point, back into either original equation to get the other variable. So you still want to end up with an x and a y as your solution. If you end up solving and you come up with a statement that's false, you actually have no solution, and these would be parallel lines. If you're solving the equations and you end up with a true statement, that's the kind that have infinitely many solutions. So with these problems, they still relate back to our three possibilities of solutions. You could have one solution, so get an x and a y. You could end up with no solution if you get a false statement while you're solving, like 4 equals 10, which is not true. And you could also end up with infinitely many solutions. So if you're solving and you just end up with 2 equals 2, that's true, but you don't have x anymore. So if that happens, you have infinitely many solutions. Let's check out some examples. So in our first example, we have 4x minus 8 equals, y equals 4x minus 8, and y equals 2x plus 10. So they're both equal to y. So in this case, let me get another color. I'm going to plug in, if y equals 4x minus 8, I can put 4x minus 8 right there in place of that y. So I replace y with 4x minus 8, and it's equal to 2x plus 10. Now I can solve the equation because now I only have one variable, whereas before you couldn't get x or y all by itself when they're both in the same equation. Now we can solve for x. We subtract 2x. Bring down 2x minus 8 equals 10. We could add 8 to get 18, so 2x equals 18. Divide by 2, so we get x equals 9. Now x equals 9 is only half the answer. We need to plug it back in and get the y. So you can plug it in either one of your original equations. Pick whichever one looks easiest for you. I'm going to pick the second one. So y would equal 2 times x. So 2 times 9 plus 10. So 2 times 9 is 18, plus 10 would give me y equals 28. So my solution is 9, 28. These are intersecting lines because they have one solution. X is 9, y is 28. And you can plug those both back into the original equations to check and make sure they're true. But let's look at another example. Here I have y equals x minus 2 and 2x plus 2y equals 4. So you have y equals x minus 2. You can replace this y with x minus 2. So let's do that. 2x plus 2 times x minus 2. Because if y is equal to that, I can replace it with that. That's the way this works. So see, now I have all x's. I can solve for x. So 2x plus, and then distribute the 2, so we get 2x minus 4 is all equal to 4. 2x plus 2x are like terms, so we're still solving. 4x minus 4 equals 4. We can add 4, so 4x equals 8. Divide by 4, so x equals 2. Again, that's half of our answer. You don't want to forget to go back and get the y. So the easiest one to plug it back into would of course be this first equation that's already equal to y. So y would equal 2, because that's my x value, minus 2. So y would equal 0. So my solution is 2, 0. Again, they would be intersecting since I just ended up with one point. Let's look at another one. Okay, so we have one more example. What if I have x minus 3y equals 14 and x minus 2 equals 0? So I don't have y equals or x equals, but in this case, I could quickly solve for x on my second equation by adding 2. So quickly, I end up with x equals 2. So now I've already got x. I need to plug it back in to get y. So I need to plug it back into the other equation. So 2 times 3, oh, that would still be y, excuse me. 2 would replace the x, so we need minus 3y equals 14. I'm back on track now. So negative 3y is equal to 14 minus 2, which is 12. We could divide both sides by negative 3. So we get y is equal to negative 4. But our final solution would be to put these two together. So make sure you put them together as a point, because with a system of equations, you're always looking for the point that they have in common.